So here we have a pretty straightforward absolute value equation. It's straightforward because it's just the absolute value bars. There's nothing inside them other than that lonely little x. And we're going to treat this more or less like a normal equation, which means we're going to isolate those absolute value bars by using a typical PEMDAS in reverse. So like if they added, we subtract. If they multiplied, we divide, something like that. So I can look at this equation and I can see that, I always mentally have this line going on here. Um, Did they add or subtract? Yeah, they added 5, so I'll subtract the 5, subtract the 5. The left side therefore becomes negative 2 times the absolute value of x will equal negative 1 and negative 5 are friends, so they combine to make negative 6. And then look to see if there's any multiplication or division to do. They multiply by negative 2, I'll divide by negative 2. And now I'm left with the absolute value of x equals a positive 3. And then here's where things get a little bit different. We're going to have step 2, which is once we know that the absolute value of x equals 3, we're trying to think of all the numbers that have a distance of 3 from 0. So basically it means that we're going to take whatever is inside of here, and we know that that number is either 3 or it's negative 3. And that's basically it. This gets a little bit more involved with the next example that's I show, which is the inside of this is going to be more involved. But basically, once the absolute value is isolated, you're going to take whatever's inside that absolute value, set it equal to this number, set it equal to the opposite of this number, and then if there's more to do, we'll do more. But you'll see that in the upcoming examples.